So in this video, we'll be looking at linear lines. So generally it's going to be some revision. You've probably done most of it in previous years. However, it's still very useful with regards to a lot of applications such as the normal of lines, the tangent of lines, as well as modeling functions. You still sometimes use linear lines. However, obviously there's not going to be a question such as graph this linear line, but rather you still need to know some of the important characteristics. So to begin, so linear line. So basically, yeah, it's a straight line. And yeah, so straight line. So what a straight line means is the gradient is constant. So that means that the steepness does not change. So you can take any 2 points, such as there and there, or here and here. Then the rise over run, or the gradient, will be the same. And so that's what they mean by straight line. So the equation that governs a linear line is always y equals mx plus c. Now, it can be in other forms, however, this is the most common. And whenever you need to work out a linear, whenever you see y equals mx plus c, in that sort of form, you automatically know it's going to be a linear line. And here you can have the gradient. And as I said, it's constant, so that's why m is just a constant. So you have the gradient there. And then c is the y-intercept. And the reason why C is a y-intercept is that you can calculate a y-intercept for any type of graph. And to do that, you let x equals 0. So for the y-intercept, you let x equals 0. And so what you get is y is equal to c, as mx is equal to 0 when x equals 0. So therefore, that is why c is often referred to as a y-intercept. So here would be 0, c. And you also, if you're drawing a linear line, you like all graphs when you're drawing, you want to label both intercepts. As we don't have an equation, we're not sure what the x-intercept is. Now, with regards to the gradient, you can calculate that by doing y2 minus y1 over x2 minus x1. This is often referred to as the rise over run. So that's the rise, and that's the run. And so graphically, you can have 2 points here. You have a point up here, which we'll say is x2, y2. Then you have a point lower, such as here. And we'll say that that one is x1, y1. So y2 minus y1 shows you the rise. So y2 up here minus a y1 will give you the rise. And then x2 minus x1 will give you the run. And it makes sense. If you have rise over run, then you times it by x, which is effectively sort of the run, it will give you the rise, i.e. the y value. Now, there's some other forms of writing linear equation. So one of them is when you have y minus y1 is equal to mx minus x1. And so this is a form you can use when you know the m, so you know the gradient, and you know 1 point. So the 1 point that the line goes through, and we'll call that point x1, y1. And therefore you can see how it corresponds. And this makes sense, as if you can think about a line, then so we'll have this equation here. And then if you're making a line, and we know 1 point on that line, so let's say that point here, and that's x1, y1, then when you're timesing the x value, so x minus x1, so let's say you're finding, you're trying to find this point here on x, then you've moved this far along in x. So effectively what you do is you can think about this as the run. And then this is x minus x1, so the run. Then you times this by m, which is a rise over run. So run times rise over run will give you the rise. And so the rise is this y minus y1. Now we know what y1 is equal to. So it'll give us the rise. So for example, it will be something like that. And then, that's a bit too high, about something like there. Then that shows us that the corresponding will be here, along this line, and you can do that for all the different other points. You can see how this equation calculates the equation of a line, because m is constant, so you're going to get a constant line going through. Another form for a linear line is x over a plus y over b is equal to 1. This is sometimes referred to as the intercept form. And the reason for this is that when the equation is in this form, you can see both intercepts. And that's because when you let x equal 0, you get y over b is equal to 1, therefore y is equal to b. And then when you let y equal 0, you get x is equal to a. So you can see the y-intercept, which is b, and you can see the x-intercept, which is a. So if you have this equation, then you know that here is going to be 0a, up here you know is going to be 0b. Down here is going to be a0, because the x-intercept goes first, and y is equal to 0 here. And up here we're going to have 0b. That's the important thing to know. Just be careful that whenever you're doing coordinates, you always have x and the y there. It's easy to get them mixed up, but whenever you see intercepts coordinates, you know that one has to be something 0 and the other has to be 0 something. So whenever you have something like this as the coordinates, you know that you may have done something wrong if it's referring to the x, and that's the y, such as I did there. Now with parallel lines, they always have the same gradient. That's an important thing to note. So these lines here are parallel, as you can see, and that's basically the definition of parallel. They have the same gradient. So they can be moved up or down, so they can be translated. However, they will still maintain the same rise over run. And that is useful, as you know that if there's two parallel lines, the distance between them is always going to be the same, as if they have the same gradient, the distance at one point, and then you move along the x, they're both going to have the same rise due to the same run. So with regards to perpendicular lines, so that's when you have two lines that have an angle of 90 degrees between them, and you can think about that as going in opposite, not opposite, but yeah, perpendicular 90 degrees. They're going to be a quarter rotation away from each other. Then there's a rule that relates to two gradients. So if you have one line, m with gradient m1, and then you have another line with gradient m2, and they're perpendicular, then you know that m1 times m2 must be equal to -1. And this is really important with regards to later when you're talking about the normal and the tangent. So with regards to this m1, m2 equals -1, you can then rearrange and say that m1 is equal to -1 over m2, or conversely, m2 is equal to -1 over m1. And just an example, if this line here, y, has 45 degrees, so we'll say that m1 is equal to 1, i.e. y is equal to x, this, as you can see here. Then we say that this line here has 45 degrees, therefore y is equal to -x, as you can see from this line here. Then we have gradient of 1 and gradient of -1. So we times 1 by -1, and we'll see that the answer is -1, which satisfies the condition as they're both, and it shows that they're both perpendicular, but that would also make sense. So I said there's 45 and 45, as this entire semicircle here is 180 degrees. You can 180 minus 45 minus 45. You'll see that this angle here is 90 degrees.